Imagine you are downloading a large file while simultaneously watching YouTube and talking to a friend on a video call. All three activities are using the same internet connection at the same time. But how does your device know which data belongs to the YouTube, which belongs to the file download, and which belongs to the video call? And how does it make sure that an important data isn't lost along the way? The layer responsible for solving this problem is the transport layer. In this video, we will explore how the transport layer acts as a traffic manager of the TCP/IP model and enables reliable communication across the internet. After completing the application layer in the TCP/IP model, we now move to the next layer, that is the transport layer. At the application layer, users interact with applications such as web browsers, email clients, video conferencing software, and many others. However, once the data is generated by these applications, it needs to be delivered to the correct application on the destination device. This is where the transport layer comes in. A transport layer is responsible for providing reliable end-to-end communication between the application running on different hosts. Let's look at its major responsibilities. One of the most important functions of the transport layer is end-to-end delivery, also known as port-to-port delivery. Let's understand this with an example. Assume there are two networks, network A and network B. Each network contains multiple hosts connected to each other. Suppose I am using host A1 in network A. On my computer, multiple applications are running simultaneously. I may have a browser open with several tabs, an email application running in the background, and a file download in progress. When data is sent from host A1 to host B1, how does the receiving device know which application should receive that data? The answer is port numbers. Every application uses a specific port number. The transport layer uses this port number to identify the correct source application and deliver data to the correct destination application. This process is known as port-to-port delivery. Another important role of the transport layer is reliability. Transport layer provides two protocols, TCP and UDP. TCP provides reliable communication. For an example, suppose a sender transmits 4 packets to a receiver. TCP ensures that all 4 packets are successfully delivered. If a packet is lost during transmission, TCP can retransmit the missing packet. TCP also provides in-order delivery, meaning packets arrive in the same sequence in which they are sent. This ensures that data remains complete and accurate. The transport layer also performs several control mechanisms. Error control helps detect and recover from the transmission errors. Flow control prevents a fast sender from overwhelming a slower receiver by regulating the rate of data transmission. Congestion control helps manage network traffic and reduces congestion when too many devices are transmitting data at the same time. Together, this mechanism improves the efficiency, reliability, and overall performance of the network communication. Now that we understand what the transport layer is and why it is important, let's take a look at what we will cover throughout this playlist. First, we will learn about segmentation and reassembly, where we will see how large amount of application data are divided into smaller segments before transmission and then reassembled at the destination. Next, we will explore connection management in TCP. We will understand how connections are established using the three-way handshake, how they are maintained, and how they are terminated. We will then dive into reliability and error control, where we will learn about acknowledgements, sequence numbers, transmissions, and checksums. After that, we will study flow control and understand how TCP prevents a sender from transmitting data faster than a receiver can process it. We will also cover congestion control and learn how TCP detects and responds to network congestion. Of course, we will take an in-depth look at the two major transport layer protocols, that is TCP and UDP. You will learn how they work, their differences, and the scenarios in which each protocol is used. We will then move on to port addressing and understand how port numbers help identify the correct application on a host. Finally, we will discuss transport layer security concepts and see how secure communication can be achieved between applications. Throughout the playlist, we will connect this concept to real-world applications such as web browsing, email services, file transfers, video streaming, online gaming, DNS, and video conferencing. By the end of this playlist, you will have a solid understanding of how the transport layer ensures that data reaches the correct application reliably and efficiently across modern networks. So let's begin our journey into the transport layer. And that's an introduction to the transport layer in the TCP/IP model. In this video, we learned what the transport layer is and why it is important and the key roles it performs, including end-to-end communication, reliability, error control, flow control, congestion control, and port addressing. We also got an overview of the topics that we will cover throughout this playlist. In the next video, we will dive deeper into segmentation and reassembly and understand how large amount of application data are divided into smaller segments for transmission across the network and then reconstructed at the destination. If you found this video helpful, don't forget to like, subscribe and share it with others who are learning networking. Thank you for watching. I will see you in the next video.